In this video, we're going to be looking at radian measures. Now, a radian is just another way of measuring an angle based on the length of the radius and the measure of the arc length for a particular angle inside of a circle. We want to remember that a full revolution is 360 degrees. And then in terms of pi, a full revolution is equal to 2 pi radians. So in a moment, we're going to look at how we can convert between degrees and radians. It is important to note that if there are no units provided on a particular angle measure, you're going to assume that it's radians. And so if there's no little degree symbol, then you're going to assume that it's in radians. To convert between degrees and radians, we're going to start with that knowledge of one full revolution. So 360 degrees is equal to 2 pi radians. From there, we can divide both sides by 2, and we know that 180 degrees is equal to pi radians. And this is really the conversion that we're going to be utilizing when we're going back and forth between degrees and radians. To convert from degrees to radians, you're going to take your angle measure theta, and you're going to multiply it by pi over 180. And this will take your angle in degrees and convert it to your angle in radians. To convert from radians to degrees, you're going to take your angle measure in radians, and you're going to multiply it by 180 over pi. And this will give you your angle measure in terms of degrees. Now, rather than trying to memorize these, which you can, a lot of times radian measures are going to be in terms of pi. So there's going to be that pi unit. So I remember that if I'm trying to convert from radians to degrees, I want to get rid of that pi since most degrees don't have a measure of or a factor of pi in it. So that's how I know to multiply by 180 over pi. And then conversely, if I'm trying to end up with radians, I want a factor of pi. So multiplying your angle by pi over 180 will result in a measure that is in terms of pi. Convert to degrees or radians. Convert degrees to radians or radians to degrees in the following examples. So again, you're going to make that conversion based on how the angle is given initially. So in example A, we've got 200 degrees, so we want to convert this to radians. And again, to do that, we're going to use that pi over 180. And this is really why this is working. So if I think about this as pi radians to 180 degrees, and then what's really happening is those degree units are canceling out. So this is just another method of dimensional analysis. And if we multiply across and simplify, we get 10 pi divided by 9 radians. Negative 8 pi over 5 radians. So now we want to convert to degrees. So we're going to take our negative 8 pi over 5 radians and multiply it by 180 over pi. Again, the idea of this that most radian measures have that factor of pi. So to convert to degrees, we want to get rid of that. So that's why we divide by pi so that we get rid of those units, that factor. So again, this is degrees, this is radians, and we can start seeing some things cancel out. So the pi's cancel out, the radian units cancel out, we're left with degrees. So multiplying across and dividing, this is equivalent to negative 288 degrees. These next examples, we're converting from radian measure to degrees. So looking at our examples, again, you'll see that we don't have the units of radians listed here, and a lot of times we don't. So that was that note we made above about if there are no units indicated, then assume that these angles are being measured in radians. There's other context in problems that we'll see that also indicate the units in which we're measuring our angle. Now, what's special about these examples is that when we learn the unit circle later in this unit, you're going to have a lot of these conversions memorized. You're going to know what 2 pi over 3 radians is equal to in terms of degrees. But for right now, we're just going to practice that conversion because we haven't learned the unit circle yet. So 2 pi over 3, we're going to multiply this by 180 over pi. Again, those factors of pi cancel out. This is equivalent to 120 degrees. 7 pi over 6, multiplying by 180 over pi. This simplifies to 210 degrees. Now I realize I'm not showing these calculations on our calculator. If you haven't already started doing so, pause the video after we've set it up and make sure that you're comfortable typing these expressions into your calculator and getting that simplified answer. Negative 3 pi over 4 times 180 over pi. This is negative 135 degrees. 9 pi times 180 over pi. Now, a quick observation, remember that 2 pi is 360 degrees. Since now we're looking at a value much larger than 2 pi, our angle measure in degrees is going to be much larger than 360 as well. 9 times 180, this is 1,620 degrees. One other comment just on making sure we have the appropriate units. Again, since the lack of any units is going to imply radians, it is really important if we have an angle measure in degrees that we have that degree symbol. Okay, working backwards, converting from degrees to radians. Again, these are going to be very common angle measures that we're going to see on the unit circle. So a lot of these conversions you will eventually just have memorized or be able to derive very quickly. Since we want to convert from degrees to radians, we're going to multiply by pi over 180 because we want to have that unit of pi in our final answer in radians, in most cases, not all cases though. Dividing that 240 by 180 to simplify this is 4 pi over 3 radians. Negative 330 degrees multiplied by pi over 180 to convert to radians. That negative 330 over 180 simplifies to negative 11 over 6, so negative 11 pi over 6 radians. (540 degrees. Again, since this is bigger than 360, when we convert to radians, it should be something larger than 2 pi. (540 divided by 180 is 3, so this is 3 pi radians. And same with example D, this 3,600 degrees. This is going to be much larger than 2 pi. (3,600 divided by 180 is 20. So this is 20 pi radians. Find the exact values for each of these. Again, once we learn our unit circle, we won't need to convert to degrees. So we're going to start by taking our angle measure in radians and converting it to degrees. Since we have all those tables, that gave us many of these function values. So I'm going to start with taking pi over 3 and multiplying by 180 over pi to get my degrees. And this is equal to 60 degrees. So sine of pi over 3 is the same as sine of 60 degrees. And we know that sine of 60 degrees is equal to the square root of 3 over 2 from our tables in Unit 1. Sine of 5 pi over 3, converting 5 pi over 3 to degrees by multiplying by 180 over pi. This is the same as 300 degrees. So sine of 5 pi over 3 is equal to sine of 300 degrees. Now, we don't have 300 degrees in one of our tables, so we're going to have to utilize reference angles. So if I think about 300 degrees, here's 90, here's 270, I'm sorry, 180, 270. So 300 degrees is somewhere in here. Here's 300 degrees, which means that our reference angle is 60 degrees. Now we also know that this angle terminates in quadrant 4, where sine is negative. So this idea of using reference angles, sine of 300 degrees is going to be equal to negative sine of 60 degrees. And sine of 60 degrees is, again, square root of 3 over 2. So this is negative square root of 3 over 2. Cotangent of 5 pi over 6. 5 pi over 6 times 180 over pi to convert to degrees. This is 150 degrees. So we're looking at cotangent of 150 degrees. Again, we're going to use our reference angles here. 150 degrees, here's 90. 180 would be that straight angle, so we're not quite to 180. So we're somewhere in here. There's our 150 degrees, which means our reference angle is going to be 30 degrees since that straight angle is 180 degrees. Now in quadrant 2, or let me rephrase, in quadrant 1 and quadrant 3, we know that tangent is positive, which means that in quadrant 2, tangent is negative. Since tangent is negative, cotangent's also going to be negative. So this is equal to negative cotangent of 30 degrees, or negative 1 divided by tangent of 30 degrees. Tangent of 30 degrees is the square root of 3. I'm sorry, 1 over the square root of 3. So this is the same as negative 1 over 1 times the square root of 3 over 1, or negative square root of 3 for our final answer. So again, we're taking this initial expression, cotangent of 5 pi over 6. We're just rewriting it. So this first step, we just converted 5 pi over 6 to degrees. Then we utilized our reference angles and the quadrants to rewrite this using a reference angle. So cotangent of 150 degrees, that reference angle is 30 degrees, but we're going to make this negative because we're in quadrant 2. Cotangent is the reciprocal of tangent. So cotangent of 30 degrees is 1 over tangent of 30 degrees. We're maintaining that negative out front. Tangent of 30 degrees is 1 over the square root of 3, or And so multiplying by the reciprocal in that complex fraction, we get that cotangent of 5 pi over 6 is equal to negative square root of 3. Cosine of pi. Remember that first conversion that we had was that pi is equal to 180 degrees. So I'm not even gonna spend time converting to degrees since that conversion is pretty straightforward. And so we're right here. We know that on our quadrantal angles, when we're on that negative x-axis or 180 degrees, cosine is equal to -1.